Okay, so now we're going to continue number 2, which is quite a difficult one, I would say. A child wishes to hit the top end of a goalpost, which is 2.4 meters high, by kicking a rock off the ground. Distance between post and child is small d. Determine vertical speed required if the rock is to hit the post when it is at maximum height of its trajectory. Now, to work this out, I've already started a diagram. This is going to be a projectile problem. This is from where the child is going to hit the ball. I'm going to call the velocity, initial velocity u, which will be at angle theta. We've got the vertical information that I need to write, horizontal information. The velocity, we have to use the components, so this one we'll call it u sine theta, and this one u cos theta. Horizontal information, velocity is u cos theta, distance equals d. Vertical information, velocity initial equals u sine theta, final equals 0, acceleration minus 9.81, and the distance is 2.4 meters. Now, what I'd like to do, I'd like to make a bit of an arrangement first. With the horizontal information, we can say s equals vt, distance equals velocity times time, and distance is d, velocity is u cosine theta, multiplied by the time, and from there I can get cos theta equals d over ut. This I'll write it there, I'll use it later on. Now, to work out the vertical speed, what I noticed is that I need the time also, so I'm going to work out part B first and then part A, because it will help me quicker to work it out. So I'm going to work out time, part B of the question. To work this out, we'll need to use s equals ut plus half at squared. Go using the vertical information. Distance is 2.4. U is u sine theta times time, and half at squared, we'll have to put in plus 1/2 times 9.81 times t squared, but the 9.1 is negative, so here put in the negative sign. This continues like this. 2.4 equals u sine theta. We have to substitute something, so I leave it. Also, to work that out, I need something else, because here I need to work out v equals u plus at, because I need to write out what is u sine theta. Final velocity is 0. Initial is u sine theta, at is minus 9.81 t, and from there we can get what is u sine theta. And now we've got what is sine theta, which I can also use for this part of the question. So going back here, instead of u sine theta, I'll write down 9.8 t multiplied by t minus half times 9.81 t squared, and so we've got 2.4 equals half 9.81 t squared when I work out the right hand side. And from there we get time. Time will be 2.4 times 2 or 9.81 square root of that, which is 0.7 seconds. So that is part B of the question. To work out part A, now I can go to this part here, which I need. And what I need to find is u sine theta. U sine theta is the vertical velocity going upwards. That is equal to 9.8 t. We know the time, so 9.8 times 0.7 equals u sine theta, and 6.87 meters per second equals u sine theta. So over there we've got part A, worked out neatly. Part B, what is the time, also worked out for us. So we can continue now. Going on to part C, show that the angle theta from the ground and initial speed of the rock obey the following equations given to us. Then theta is 4.8 on d, and v squared equals gd squared on 4.8 plus 4.8 g. Okay, so now we're going to set out on this part. From here we've got the equation of what is sine theta. I'll make sine theta subject of the formula because that one I'm going to use it. So sine theta is 9.81 times 0.7. Actually, u sine theta is 9.81 times 0.7. And sine theta, subject of the formula, instead of 9.81, I can write down g times 0.7 is time. I'm going to leave it as letters for now. And division by u. This is what is sine theta. Okay, excuse the writing because it's difficult to write when holding the camera at hand. We also know what is cos theta, as we said before. Cos theta equals d over tu, which we proved earlier. To get tan theta, we divide sine theta over cosine theta is tangent theta. That will be, instead of sine theta, gt on u. Instead of cos theta, we got d over tu, which becomes gt on u. And dt on u, we take it to the top and it becomes the other way around, inverse, when you multiply. So it becomes tu over d. We can see that the u's cancel. At the top we have g, t times t becomes t squared over d is tan theta. And the part at the top, we can work it out now if we want to. It becomes 9.81 times 0.7 squared over d, which we don't know. And 9.81 times 0.7 squared is 4.8 over d, which is the first part of part C. Calculate what is tan theta. And finally, to get the second equation, what I need to do, I'm going to use a mathematical equation, which is sine squared theta plus cos squared theta equals 1. That is a mathematical equation. Instead of sine squared theta, I'm going to use gt over u all squared. So it will be gt on u all squared. So g squared t squared on u squared. Instead of cosine theta squared, I'll put d on tu all squared. So squared, squared, and squared equals to 1. We can see that we've got u squared in the denominator. We'll get rid of it by multiplying everything by u squared. And it becomes g squared t squared on u squared times u squared plus d squared on t squared u squared times u squared equals u squared. These cancel. And these cancel also. Over here we can say also s is ut plus half gt squared. When you throw the object upwards, initial is going to be 0, distance 2.4, half gt squared. This goes at the top, it becomes 4.8 equals gt squared. And over here, I can arrange it a bit to get gt squared. I can say that g times gt squared, nothing else, plus, g times gt squared plus d squared over t squared equals u squared. Here, instead of gt squared, I'm going to substitute and put 4.8, and we'll get g times 4.8 plus, instead of d squared, instead of t squared here, I'll substitute here 4.8 over g equals t squared. That will substitute over here. So here we'll get d squared over, instead of t squared, put 4.8 over g goes to the top equals u squared. And I think it is what we need to find, because now I just arrange it and we get 4.8g plus gd squared on 4.8 equals u squared, which has to be initial velocity squared.